My sound is on, we're recording, we're going over fetch and JSON today. So fetch and JSON are concerned with this same exact transaction, right? On the screen here, we have the same transaction we talked about last time. You have a client, you have a phone or a laptop or a browser, and that laptop wants to send or request information from a server. And so they send an HTTP request message to a server. And then the server responds back and says, this was okay, or this broke. It gives you a response message back. Last time we talked about like forms, and we used a form, and we actually had a client, and the form was sitting on the client, and then that form was submitted, and it contained all this form data with it, and all that form data came to the server, and that server was something I put up, and it just saved it, and then it sent back something else to the client. Like that's what we did last time. Instead of form data, a really popular way of sending data around the web is with JSON. So JSON is another way of kind of having data to be able to trade it around the web that almost all applications use and understand. So this is what JSON is, and it looks a lot like JavaScript. And in fact, the name of JSON is JavaScript object notation. That's where JSON comes from. So it's going to be like very familiar to your JavaScript object. So you open with a bracket, and then you have key value pairs where the keys are always in strings, and then the values can be booleans, numbers, or strings, or like arrays or other larger types. And most of the web kind of trades information in this way. And most APIs send back and get information in this exact way. And this is exactly what I said, right? JavaScript object notation. The one thing I want to point out is that it's not the exact same as the object. If we really get in here, you can see the object, title, and author are both keys, but they're not in strings. In JSON, they have to be in strings. It's not going to accept them as just regular. It's going to throw an error and say invalid JSON. So then how does JSON work with fetch? So fetch is a library that's available to JavaScript programs in the browser. So any JavaScript program you run in the browser has access to this library called fetch. And fetch is a way of retrieving and sending information. And it's usually going to retrieve and send information in JSON form. At least in this class, we're going to practice receiving, sending information in JSON form. So instead of using a form to submit, you can just submit information on your own, or it gives you a chance to say, did this form pass all validation checks, and then send it as JSON. The one thing I want to note about fetch is that's going to be our first asynchronous library. So going back to this picture, this server it could live a long way away, right? The server could be thousands and thousands of miles away. It could be in a different time zone. And so asynchronous programming is, we don't want, like if we're running a script and we come upon like a call that says, hey, I want to send this somewhere else, we don't want to stop the rest of our program from executing. Because that could take like 5-10 seconds. It could take a long time to run through that whole thing. And so asynchronous means I'm running through this script, I send a piece of information, and then I have something here called like a promise or a callback, and I don't execute the rest of my code until I get a response back, because I want to actually do something with that response. So asynchronous just means you're waiting for a response before you're continuing to act. Synchronous just means everything goes one by one in a line. Asynchronous, you're waiting for a response, and then continuing to do something else. And then synchronous means everything's just flowing in a single script. So let's do an example. Let's clone down. So I'm going to go into my code directory. I'm going to go into LC101. And I'm going to find fetch JSON, clone it down to my computer. All right, I got a lot of examples here, right? We got 4 different examples here. So if we look at all these, we don't need to be looking at them all at the same time. We can open one folder at a time. So if we look at fetch example 1, and this is the exact same example that was in your reading, right? And we can open up fetch example 1, example.html. What the web page is doing is it's going out and getting this information and displaying it to the screen. And this is what our code looks like. We're saying, hey, when the window loads, let's use this library called fetch. So I don't know what the weather is. My browser does not know what the weather is. When we log into this web page, let's use this browser fetch. And let's go get the current weather. And that weather is returned in JSON format. Then, after the rest of the information comes back, then let's actually do something with that response. So 2 things out of this. I want to look at the JSON, and then I also want to talk about asynchronous programming. Okay. So what's going to happen is we're going to load the window. When we load, I'm going to say, hey, our program is starting off. Then we're going to send a fetch request to get that JSON back. When that JSON's back, we're going to execute all this following statement. At the bottom here, outside of this fetch, I have a different console log. In what order are these things going to actually log? Like, is it going to go line 8, line 10, line 26? I heard 8, 26, 10 over there. Let's see. Open up our developer tools. So we have line 8, line 26, and line 10. So what's actually happening here in the code as far as like asynchronous matters? Our fetch is going out and like traveling to a different API, a different server on the internet. And in the meantime, while it's traveling, we're executing the rest of our program. So if you're dependent on those results, if you need those results to get back, you can't just put it below. You need to put it inside the block. We need to put it inside the block, because if it's outside the block, it's just going to keep on executing. If we go to network, we make this a little slower. Oh, slow didn't even matter. And here is the request in our actual browser. This is our like fetch request as the browser is seeing it. It's saying, hey, I went out to get HTTP weather.json. I got back a 200 status code, like we're good to go. And then if you click the response, you'll see, okay, what did it actually give me back? And it handed us back this JSON format, which is like, okay, this is, I can make this into a JavaScript object. I know what to do with this. This JSON format in our fetch example, that's the same thing that we get by calling response.json. So when we call fetch and then .then, the .then is going to trigger when that response is actually back. And then if you want to get the JSON out of that response, you can say response.json. And then this JSON is like a JavaScript object that you can use, you can play around with. You can put it on the screen, you can print it out, you can change it. You can use that data that you got back from the website. In this example, what we're actually doing is saying, hey, with this data we get back from the website, let's put it to the page. Let's show it to the page. Let's say, give me the div of weather stuffs, and let's shove all this stuff inside of weather stuff. So let's do one together. If we go to fetch example 2, we have a brand new fetch, and we're going to fill it out. So we open fetch example 2 and there's nothing there. In our code for fetch example 2, we have a div filled with comments. Just to make sure we have something on the page, we can print a header that says, hey, we're going to print the comments, right? Now what we have to do is go get these comments from a different API somewhere on the web. And so we do that using JavaScript. Here in line 10, we're saying include this other JavaScript file. And so if we go over to assets application.js, this is the other JavaScript file that we have. Now this JavaScript file is already included, and we can prove it by console logging hello world. Now when we refresh the page, that JavaScript file is there. So now we're going to use fetch to actually go get that data. And we actually have an API here that we can go hit. So we can use fetch, and using fetch we can say go get me from this URL. So I can say fetch this URL. Screen's going out. So that's all we're doing. We're console logging hello world, and then we're saying, hey, fetch me these comments. If we come back to our page and refresh, nothing's changed, right? We aren't doing anything with the data, but how can we check if we actually got the data? Yeah, network. We go to network and we say, did we send a request? Comments says, you sent a request to this URL. You wanted to get it. It returned you a status code of 200, a lot of headers, and then these are the actual things it sent back, which is a lot of JSON, right? This is a lot of data to put to the screen. So then let's do something with it. So using fetch, which returns a promise, we can say then and this is the syntax of saying, hey, go get this web page. When the web page returns, dot then do something. In order to get JSON out of the response, we say, oops, that's the wrong. We say take response.json, which is also a promise, correct? And we should be able to actually get the JSON out of that response. And there it is. It is a length of 500 little pieces of JSON. So that's a ton of data that it just sent over the internet. That's a lot of data. You have a question? Yeah. I thought somebody had a question. Yeah. So the question was, can I just explain what I did there? Because it was a lot. So line 4. Line 4 is saying fetch https JSON placeholder dot tippycode.com/comments. So fetch is a JavaScript library. So what that line is saying, go get me the information that lives at this URL. Like go fetch it for me, go get it. When that information comes back, .then, when that information comes back with the response that it gives me, then I want to get the JSON out of that response. Like that's the JSON that I want to get out of the response. When I get the JSON out of that response, which is this next .then, I just print it to the screen. So go get me the information, give me the JSON from the response, then print it to the screen. Yeah.
So if after fetch we're pulling just the JSON, what all does fetch?
Let's look at it. Question was, does anybody know? Like, are you saying like, what is this response if it's not just JSON? Yeah, because if all we care about is the JSON, then what else is it returning? To figure that out, let's debug. Does anybody have any ideas of what else it returns? All right, let's check it. All right, so we have our debugger here. We have stopped. We've gone and got the information. Now we're back. We have the response, but it's not in JSON format yet. So what is it? It says I got my status. So it's like you were correct, right? It was a successful request. And then it also says this is the URL that I'm coming from. So I guess it's just like a bunch of metadata about the response you're getting back. So like you could have in your code that says, hey, if they sent me back an error, then don't display the JSON because there is no JSON. Like if the status code isn't 200, then I need to stop. I need to pump the brakes because there's no JSON in there. Yeah.
Where I'm struggling is, and I'm probably focusing on the wrong thing. So you said it's from a library, a JavaScript library. How do you know that file exists?
Yeah.
Put it in perspective, like in the real world, how do you know to go fix that?
Oh, okay. So the question wasn't how do you know that fetch exists, but how do you know that if you go to this URL, they'll give you something back?
Yes.
Yeah, that's a good example. So you don't ever know 100%. And this is just the exact web page, right? This is just proving if I go there, these things load up. This doesn't answer your specific question. Your specific question is, how do I know where to send requests to, right? Like these URLs, where like they exist. So, yeah, there's a ton of web servers out there. Like every front end application has their own web server, and usually like the web address that you're sending it to is like the physical location, ends up being like the physical location of wherever somebody's machine is stored. So normally if people want to have a server available for other people, they'll just like put a post up and document it and tell people about it. If you're writing your own client, like you're writing your own HTTP client, like you're writing your own web page, normally like if you're in a business situation, you'll also have a team that's writing a server and they'll tell you, hey, here is the API endpoint. Or even better, if you're full stack, right, you might write the client and write the server, and then you know your own endpoint. You could say, this is where I want my client to always talk to. But there's no like way in the code to find it. It's just somebody has to tell you, hey, I have this web server running, and you can get this resource by connecting to it here.
I'm just trying to wrap my head around, and I struggle with it because it's like thinking ahead. How would I know to go look for something?
Yeah, somebody has to publish and say, hey, you can go to this URL and look for stuff. Like I published an API, and the API is like that same server. That's like the synonymous with the server. Any other questions before we actually do something with this data?
So I'm seeing two .thens.
Yeah.
And I'm kind of confused because there's a little difference in reading. There's one like the .then response and then just the other one tacked on to the end.
They have it right here, right? Oh, so my .thens are a little out of order.
You kind of stacked them rather than having like separate ideas.
Yeah, it'll work both ways. So it'll work this way too. Essentially, both things that are waiting are saying just wait for this to complete and then do my action after it. When I had it this way, I was saying, okay, wait for the fetch to complete and then return from this call, from line 7, return response.json. And I'm saying, okay, now wait for that to complete and then do something else. It's the same thing as saying just call response.json and return for it to complete. Yeah, question in the back.
Can the dot then stand alone, or is it like standard dot notation that needs something to write on?
Say that again.
Can the dot then stand alone code, or does it need a response or a function to be, or a fetch to be attached to?
Yes. It needs something to be attached to. So if I only have line 5, it's going to fail compiling, and then if I run it, it's going to say, I don't know what you're talking about. Because, where's my web page? Oh, here it is. It's going to say, I don't know what the period is, because .then is only used for an asynchronous event. And an asynchronous event, it doesn't have to be a fetch, but any asynchronous event that says, I'm going to do something, and then you're going to wait for it to be done, and .then, and then when it's done, .then, you're going to do something else. So this is really helpful in the web because you would never want to stop a web page for loading when you need to request tons of information. Like think of Facebook, right? They'll start displaying stuff to the screen as they're going and getting other information and putting it to the screen. Because a lot of times if you wait your web page to load, if it takes too many seconds to load and you show them nothing, then they move on. They want to see stuff so you can show stuff to the screen while you're loading and putting more stuff in. Let's go into example on .then and talk about that a little more after this last question. Right here. I just named it JSON because I know it is going to be JSON coming through. But if you wanted to, this is just a variable name. So you can name it whatever you want. And it's the same thing with this response. All right. So let's show this to the screen. And then after we show that to the screen, let's go a little bit more over promises. But I'm going to switch order, and I'm actually going to, let's put this to the screen first, right? So now we have this JSON information. We refresh our page. We print it to the screen. There's 500 of them. So what do we do with that 500 piece of information? Let's shove it in there. So if we go to our index.html, we have a div with an ID of comments. And so we're going to want to put all of this inside of comments. The first thing we have to do for that is actually get comments, right? So we can say get my comments tag. And get element by ID from the document. So now I have my comments tag, and I'm going to try to fill in all this stuff under that comments tag. So I'm going to print out comments tag, and all we're doing here is saying, okay, from the document, go to this ID and then retrieve it for me. And I printed to the screen my comments tag. So what would be a good way to display 500 comments? Yeah, maybe some type of we have to iterate over them, and let's try to create some type of list. I think I heard somebody in the back. So let's try it. Let's try just displaying like one thing first, and then let's display 500. So if we have a list item and that list item is hello world or hola mundo, how would we add, let's see if I can append, I think there's an inner HTML tag. And all I want to do is say, can I even insert anything to this list? And I'll flip back to there. And so it showed up on the screen, and I'll explain what I'm doing here, right? So in line 9, I'm saying, hey, give me the div that holds all my comments, and then make me a new list item, and just shove that into the div. Put that inside the comments tag. Now, we don't want to do that with one list item. We want to do that with all of the JSON that we get back. So how are we going to, yeah, I like it, loop it. And how much do we count to? Yeah, so I changed mine to var name. Let me change it back to JSON. So start at 0, continue on until you get to json.length, whatever that is, and then add 1 each time. This is our normal list, right? And then let's get a comment to work on. So every time we iterate through, we want to say, give me a new comment. And then the next part is, let's shove that comment into our comments tag. We can remove our old testing code. So this still isn't quite going to work, but it's going to be getting us closer and closer. Yeah. Yeah, so the question was, do we need to concatenate the tags on either side of the comment? On either side of the comment. And the answer is yeah. So what tag should this be? Like, what should we make this a tag of? Okay. So each one is an ordered list? Each comment is an ordered list? So a list item. So each one of these is going to be a list item. Okay? And I'm going to use string interpolation to make this a little simpler. Okay. So now we're saying each comment is a list item. And then every time through, let's put that in the comments tag.
You might want to plus equal instead of equal that comment there.
Yeah, because else what's going to happen?
It's going to replace it just one time.
Yeah. So we want these to happen 500 times and it replaced it just the one time. So we can try plus equal. We refresh the page. And look at it. It's beautiful. What is going on?
Just the object getting broken out the piece of the object.
Yeah, I'm just saying, hey, put the object on the screen. And then so JavaScript is like literally trying to put an object on the browser. And the browser's coming back and saying, I don't know what to do with that object, so I'm just going to say this is an object. Where really that object we proved had like, we go back to the network tab, That object has a ton of information. It's just we're not doing anything with it. So what is the piece of information that we actually need from this object? Yeah, let's say body. We need the body from this object. So we can go back here and say, okay, from my JSON, give me the body from that object. And if I was to write a little cleaner code or code that could be understood a little bit more, I would say, let my comment equal to my JSON I.body. Let my comment tag equal to my comment, and then add my comment tag to my HTML. This is a little more readable. Now you know exactly what's happening here. All right, we're getting closer. It's still not beautiful by any means, but we're showing all this information to the screen. With any list, what I want to point out is we should probably start it off with a list tag. And then finish it with a closing list tag. Oh, that's not exactly right, is it?
Yeah, I ran into that before. I noticed that it'll automatically close things as soon as it runs that.
Nice.
So I'm not sure to avoid that.
Yeah, in our scenario, how we could avoid it is we could just say we want to put our list here, you know. And then instead of targeting comments, we can just say, hey, I want to comment my comments list. So if you know that something's going to be on the web page, then put it on the HTML ahead of time. And there we have our comments in an ordered list now. And if we come down here, we have ordered list and all these list items.
Sorry, can you go back to index.html, please?
Yeah. So this is how a lot of web pages will start adding their stuff to the screen, right? We're going to start off with like a basic framework. A lot of web pages you visit start off with like a basic framework, and then they send a request to get information, and then they start filling in that basic framework. All right, the last example we're going to look at is like promises. And I'll commit this code and push it up to GitHub. We're just going to talk about 5 minutes more about promises and talk through like a few of the more like stickier points about promises, I guess. All right, so I'm going to close out of that example, and I'm going to bring up my promise example, promises.js. So this is not in a browser. This is just Node code. And in fact, if we wanted to make this a little easier, we could just run it in a REPL. All right, so a promise is something that is asynchronous. A promise is when you say, I'm going to do something, and that thing might take a while. Like it might travel to another piece of the internet and get a piece of information, or it might set a timeout, or it's just going to do something that's time consuming. So continue on, and then when I get back, I'll tell you when I'm back. So our promise before example was fetch. So if you look at the documentation for fetch, fetch actually returns a promise. So fetch returns a promise. When we go over promises, it's kind of like going over fetch without going to get something. So here we're saying, okay, give me a new promise. Inside of that promise, so what I want to execute inside that promise, I want to set a timeout. I just want you to wait 4 seconds. I want you to wait 4 seconds. After you wait 4 seconds, then resolve my promise with hello world. So, we're good to go. When I use .then to chain on top of a promise, I'm saying don't execute the code in line 11 until the promise finishes, until we get something back. So in our example, the promise is going to run. It should wait here on line 10. Like it shouldn't execute line 11 for 4 seconds. It should wait to execute it. And then it should continue on. So let's run it and see if that happens. So I started it. It just finished. So that's like an example of like a long API call to a different server across the country. You've started something, you're waiting for it to get back. When it gets back in line 11, we printed hello world. Program finished, we're waiting for it to get back. In line 11, we're printing hello world. And then the interesting thing about this is the rest of the program is going to run. Line 16 is going to print, but we're still waiting for that response to come back. Promises also give a cool way to chain things on. So when we saw 2 different thens earlier, you can say, okay, well, after I do that function, then I want to do a new function. And you can just keep chaining these on one by one by one. And line 14 now is not going to execute until after the promise resolves, so after the first 4 seconds. And then it's not going to execute till after line 11 is run. So we should see line 19, wait 4 seconds, and then line 11 and line 14. Why are we printing out undefined in line 14? Yeah, because I haven't returned anything from this function. So we're calling .then on the return value of lines 10 through 12. So if I wanted to return something from this promise, then that value will be available in my next promise.
Curious question then.
Yeah.
Assuming that starting at line now 20, you have lots of things going on that takes more than 4 seconds. How does it deal with, I'm in the middle of running another thing and my promise gets back?
Yeah, it's gonna wait. So the question was for the people who didn't hear it. Say you have 1,000 lines of code after line 20, and that takes longer than 4 seconds. And then you have a new thing. Anything that is synchronously, so anything that doesn't have to wait for a response, is going to run in a row. And then when that's done running, it's going to run the asynchronous stuff.
Okay,
so it doesn't, even if it gets back and the program is still running, it's going to wait till the program's over.
Cool.
Yeah. A cool thing of asynchronous stuff is you can have multiple asynchronous stuff. You can send 10 web requests out. So a lot of web pages, say let's use Facebook for example, they'll send web requests out and they'll say, okay, first give me this person's feed, but also give me this person's friends and also give me this person's this. And they'll send like 6 different requests out at once. And then as they come back one by one, they'll say .then to each one of them, and they'll start adding them to the screen one by one. The last thing I want to go over is .catch. .catch is used for errors. Like what happens when your program breaks? Like what do I want to do with it? So there is a way to reject a promise or to like break a promise. So you get a response back from a web interface and it's a 500 error and you want to .reject and you want to blow up your program. So we can say, hey, I want to reject, and then it's going to actually skip all of these .thens. So once you throw an error or once you reject, it's going to skip all of these and it's always going to jump to .catch. You could have like 20 .thens in a row. It's going to skip all the way to .catch. So I ran line 19. I'm waiting 4 seconds. Oh, well, that's not 1 second. My error is the same as it was before. So I printed that out here in line 18. It skipped all this stuff here. Let's see what happens if I resolve, right? So I resolve, it should go through all these stages. It should wait 4 seconds, it should resolve, it should print it in line 11 and then line 14. Like that makes sense. What happens in here if I'm going to say, throw me an error, hey, I broke. What happened? It didn't kill the whole program, but it did do this. So it ran the set timeout, it waited 4 seconds, it ran line 11, and then it didn't like, blow up red, but it did stop here and it said, hey, when you threw an error inside of this promise, immediately skip to the catch block. So it did not continue, it did not print out line 16 now. So we have no line 16 response. We actually skipped from this response to line 18 through 20. Question? Say that again.
Why did it come out the word error colon? Why did it not
Because that error isn't just like a string, it's like a whole object that isn't an error type object. It's like an error class. So that error that I threw is like the whole thing that comes here in line 18. Any other questions before Studio? So I did not get to the example of that kind of mimics assignment 5. So I'll just have to do that tomorrow and upload it. And then I'm going to grab Greg. So don't go anywhere. I'm going to grab Greg. And as I grab Greg, I'll answer this question. Let me stop the recording. Yeah.